Hey everyone, this is my final project for CSC 594, Topics in Artificial Intelligence, Natural Language Processing. So my project is training a long short-term memory neural network on a few different NLP-oriented tasks. So let me skip the requirements for now and go down to the proposal. So I outlined 3 different tasks in my proposal. The first task is to use an LSTM neural network to do novel text generation. Second task was to again do novel text generation, but this time instead of training it on character by character, we would train it on word by word to see how that improves the model. And then my final task was to train an LSTM neural network to classify words and determine their part of speech tag. So let's actually go back up and start from the top. So for this project, I was using Python 3.5, NLTK for their part of speech tagger, NumPy, Pandas, scikit-learn, TensorFlow, and TF-learn for all of this. So if you plan to run this, then you should install all those. And then for TensorFlow, try to install the TensorFlow GPU version because that will speed up training times. So continuing down, the first task that I tackled was generating text character by character. So a bit of information on this. I used a dataset consisting of 419,000 files of guitar tabs. And my goal here is to generate new guitar tabs based on all of those. So first things first, I loaded them all in. I set a max sequence length, which is basically how long the LSTM neural network can look back to then create the next output, to 128 characters. And then from there, I read in the data set. So one issue with the dataset is that it's so large that I couldn't read all of it in. I had to take a very tiny portion of that, which is only 419 files of the 419,000 files. And just in those 419 files, I already had over 2 million characters. So future work, of course, is to train this in the cloud so I could actually read in all of those files and we can see what it outputs. But for now, I just chose to take a smaller sample of the data set and see what we can get. So here we use a TF-learn function to generate redundant sequences. So basically this will split up the any given input into whatever sequence length that we've chosen, which was back up top with 128. And this is required for the tensor that we have to feed into the LSTM neural network. So I'll get into that in a little bit. After that, we just take a look at the dimensions of our data. And then finally down here, we can start building the neural network and training it. So as stated previously about the dimensions of the tensor that we need to feed into the LSTM neural network, it has to be a 3D tensor. So in our case here, we have 690,000 sequences, which is basically every line from those guitar tabs split into chunks of 128 characters. So we have 690,000 of those. And then our next dimension is the sequence length, which was 128. And then the third dimension there is the number of unique characters. And in the guitar tab files, there were 132 unique characters. So yeah, here we set up the neural network, and then I have this helper function to perform a single run of that neural network, feeding in that small sample of input data. So we do a run. It takes about 720 seconds to perform. And then we can actually tell the neural network, okay, let's take a look at the generated text just from this run. And then So it says temperature of 1.0, and I'll go down here to explain that real quick. Temperature of 1 means that the neural network is trying to create fully new text, novel text. Temperature more near 0 means we're just going to basically mimic the input data. So as you can see here with a temperature of 1, since we only did a single run on this, it does have some output that's exactly from the training set, but then as you see down here, this output is novel, and you can tell there's some gibberish going on, and this guitar tab isn't structured correctly, but overall it's starting to understand the structure of the text. It knows that chords are placed usually above the text, things like that. It's pretty cool. And then down here we generate a sample with a temperature of 0.5. So this is more like the training set, and all we get is song lyrics verbatim output. So I make a few observations, and then we do another run. In this run, we output some more generated text, and as you can see that the guitar tab here is a lot better than the previous run. It's definitely structured better. We're starting to get multiple lines stacked. Ideally looking for just a 6-string guitar, but it's not there yet. And then with a temperature of 0.5, we get some exact output from one of the training samples, and then a bunch of blank lines for no good reason. So there I actually stopped running the what time is it? Shit, I'm already at 7. Okay. This is gonna be longer than yeah, this will be longer than 8 minutes, and hopefully not longer than 10. So a few observations here. I used TensorBoard to monitor the loss value and how that's decreasing of the neural net, and these all look like pretty healthy graphs here. It's pretty cool that you could do that with TensorBoard. So on to the next task. That was generating novel text word by word, and I chose to skip this task because it's I don't think it'll be as interesting as doing part of speech tagging, which is similar to what we had to do in homework 3. So moving on to that, we have data from homework 3, which I read in, and I'll use that for this task. So I outline like a plan of where or how I'm actually going to be doing part of speech tagging with the LSTM neural network. But basically, I'm going to be reading in that homework 3 file, which I can pull up real quick. Here it is. Which contains a word and then the part of speech tag. And this is in, I think it's IOB format. So I read all of these lines in just as we did in homework 3. I use NLTK to give me the sentence, the tagged sentence, and then I generate a tensor basically of, where is it? Here it is. The number of sequences. So we have about 9,000 sentences, and each of those, the longest sentence that I found was 78 words long. So I add a start and end tag. So that brings the longest sentence to 80. And then 80 words long. And then our last dimension is for both the part of speech tag and the word that was. So the LSTM neural network needs a time series input, and what we're treating as time is the word that comes after the current word. And then just to tag every sentence with a start and end, and then also unknown tags, that makes sure that every sequence is of the same length. So continuing down, this is just encoding the tags in a one-hot representation, which is just easier to, well, not even easier, it's just required to determine what class is output from the LSTM neural network. So I do a little verification there. And then here's the heart of preparing our input and input X and Y data. So this is just preparing the tensors. Do a little verification on this. And as you can see, I print out one of our examples, which is, okay, we have a start word with the start tag, and then each of these words is tagged, and the integers next to it are the integers that index into an array, and that's what we actually train on, because you can't train directly on strings. So continuing down, and at this point everything looked good. We had our input data prepared, and now we're starting to build the LSTM neural network. So this is all great. And then for this task, this will be a sequence to sequence LSTM neural network. There's other forms of classification that you can do where you take in a sequence and then you classify that entire sequence as just a single or some class. But for us, we need to classify every single word in this time series, and that's why we need to do a time distributed layer. But I ran into issues with this. It's actually a bug in TF-Learn, and right now this time distributed layer is broken. So I'm not able to actually see if the output of this is correct or what the performance of this LSTM neural network is on this data. So of course, future work is to wait until they patch this, which they've actually done, but it's not in the released version yet of TF-Learn. So hopefully that's coming in the next few weeks. But I'm pretty sure everything in terms of the input data is correct. So yeah, once they fix this, I will run this and see how it does. But overall, that is my project. I definitely learned a bunch about LSTM neural networks, how they can be used in natural language processing tasks. They're perfect for time series data, and you can treat time series as character by character, word by word, or I think there's some tasks for LSTM neural networks that treat, say, sounds as their time series data for like speech recognition. So these are amazing, amazingly useful, and yeah, I can't wait to see how they perform on this task. So that's all for my project. Thanks for watching.